Welcome guys, this is Gagan from lifelearnings.com and this is the part 2 of fourth video tutorial for PIC16F886. In this video tutorial I will show you how you can simulate this program in Proteus ISIS. So let's move to the Proteus ISIS. So when you open this software, first make sure you set the display options with this OpenGL graphics if it is available. Now start with adding the components to the device list. For this you have to click on this second tool, this is component mode tool, and click on this P to place the components or to pick the components from the library. Now for my PIC16F I need that microcontroller package, so type PIC16F886. Select this package and click on OK. Now the device is available in the list, you can see. Now how to place the device on this screen? Select the device and place the device on the screen. You can zoom in and out with mouse scroll button. So let's zoom into this package. Now this is our microcontroller for simulation. No other component required to put this model into simulation. Double click on it and it will provide you this pop-up window where you can set the processor clock frequency. So in my case I will use a 16 megahertz crystal, so the processor clock frequency must be 16 megahertz, or it must be the same frequency as we set in our compiler. So you can see in compiler the set frequency is 16 megahertz, so it must be same for simulation model. So go back to ISIS and change the clock frequency. So next is the program file, and we will give a path to the hex file generated by the compiler. Now for a moment cancel this window and let's go back to compiler. And how you can generate a hex file from this code? Just go to build and build or compile the program. So if your program finished successfully, that means there is no error in the program and your hex file is generated. So the location of this project is on desktop. If I go to desktop, this is the folder. So when you open that folder, you will see one hex file. It is generated by the compiler. Now we need this hex file location for simulation model. Let's go back to ISIS. So again double click on it, and now processor frequency 16 megahertz, and just click on this folder icon and browse for that folder which contains your hex file. So in this case it is on desktop, and in this folder you can see test1.hex. so when you select this file, click open, click OK, and now your model of microcontroller is ready for simulation. So how you can start simulation? You can see this button for play the simulation. So click on it and your microcontroller is on simulation. You can see the time is running here, and if I focus on the pins of this microcontroller, you will see a gray color on each pin of the microcontroller. Let's stop the simulation and go back to the compiler. Now if my program is port C is equal to 0x01, now suppose this is my program, I want to put 0x01 on port C. First I will compile it. So it is compiled successfully, and go back to ISIS. Still there is no change in the state of pins of port C. Why I am not getting the output on port C? Okay, I want to tell you that the process is not straightforward. You can't put data directly on the port without assigning its direction. So now what is a direction? We have a tri-state resistor. The name of the resistor is TRIS, tri-state. But for which port? I need the tri-state resistor for port C. So if you are using port C, you have to configure the tri-state resistor C. If you are working with port A, you have to configure the tri-state resistor A, or if you are working with port B, you have to configure the tri-state resistor B. Then only you can use your microcontroller port pins for inputs or outputs. Now let's see what is this tri-state resistor. What is the necessity of this tri-state resistor? So open the datasheet of microcontroller and you can refer to input output port section, go to port C, and you can see port C and tri-state C resistor. So when you read this first paragraph, you can see setting a tri-state C bit is equal to 1 will make the corresponding port C pin an input. Clearing a tri-state C bit is equal to 0 will make the corresponding port C pin an output. So that's why in very first program we were not configuring the tri-state resistor to configure the port C as an output. That's why we are not getting the output in simulation. So for making the port C, the entire port C for an output, we have to assign 0x00 to tri-state C. So now let's compile. The shortcut to compile the program is Control F9. So when it get compiled, go back to ISIS and now click on the play button. Now you can see port C status is 1, then all other pins are 0. So this port RC0 is 1 and remaining all other pins are 0. Why I show you this in second part? Because it will be easy to remind this state that you have to configure the tri-state resistor every time before using the port for any purpose. So I am using only port C, that's why I am dealing with the port C here in the simulation. There is no state of high-low on any other port. Instead of 1, if I put value 2, then if I compile the program by pressing Control F9, so what will be the status on the port? You can see this signal shifted to this side, so this is 2. Stop the simulation, go back to the compiler, change the value to 4, again compile it, Control F9, go to simulation, and you can see 4 on next pin. Next pin is for 4. So in this way you can put any value to port C, but port C is an 8-bit port, so 2 raised to power 8 is equal to 255. So 255 in decimal is equal to FF in hex. You can't write values more than this value on a 8-bit port. If I write 0xFF, then what will happen? This instruction will make all the pins of port C is equal to 1. Let's see. So you can see at a time all the pins of port C are high. Or if you write 0x0F, then higher 4 bits will be 0 and lower 4 bits will be high. It is true. Higher 4 bits are low and lower 4 bits are high. So in this way you can write any 8-bit value to port C. Now what about port A and port B? Why I don't discuss those ports at startup? Because when you take a look on port A and port B, you will find some of the analog channels. So if you go for port B, RB0 is also AN12, RB1 is also AN10. First we have to disable the analog channels. So how we can disable the analog channels on port A and port B? You can go to input output port section of datasheet and we have this resistor ANSEL, analog select. The meaning of this resistor is analog select. So if you clear this resistor, then you will get all the pins for digital. You can see the comment for digital input outputs. So to make port A for digital, first you have to write on ANSEL is equal to 0x00. To configure the port A for input or output, we have to configure the tri-state resistor for port A. So tris A is equal to 0x00 for output. It will be same for port B, but the resistor name for disabling the analog channels is ANSELH, analog select higher. To disable the analog channels on port B, resistor name is ANSELH is equal to 0x00. So this will disable the analog channels on port B. So again, I want to configure the port B for digital outputs. So the resistor tri-state B is equal to 0x00. Now your analog channels are disabled. Your all ports are configured for output. Now you can write the value for port A. Any value you can write, 0x F0 suppose. For port B, 0x FF. So in this way you can write any value to any port for digital output. Let's compile it. Okay, so there is no error. Go to simulation and now hit the play button, and now you can see the status on port B is F here and F here because of the value FF on port B. Now port A is equal to 0x F0. So F0 means higher 4 pins must be F and lower 4 pins must be 0. It is true, but you can see these 2 pins are not high, pin number 9 and 10, because we are using external crystal and these 2 pins are required to connect the external crystal device. So we can't use these 2 pins for inputs and outputs because these 2 pins are reserved for crystal device. Now if you want to save this simulation file, go to file and save design. So I want to save the design on the same folder so that in future I will get all the files in the same folder. So it is on desktop. Open this folder and I will give a simple name to it, design1. So your design file is saved. So guys, for a quick recap, you can't use any port of the PIC microcontroller without configuring the tri-state resistor, and every port have its own dedicated tri-state resistor. Like for port C, the resistor name is tri-state C, port A, tri-state A, port B, tri-state B. If you have analog channels on port A and port B or on any other port, you have to first disable those analog channels so that your port can work for digital input outputs. So in this microcontroller, to disable the analog channels on port A, we have resistor ANSEL, analog select for port A. For port B, we have analog select high resistor. So if we clear the resistor bits, the pins will work for digital input outputs. In third part, I will show you how you will download the program into microcontroller with the help of PicKit2. And stay in touch guys, I will provide further video tutorials on PIC16F microcontroller series, and thanks for watching.